Recorded. Okay, good morning. Welcome to week 10. Okay, so we are starting the next unit, which is on graphs. Welcome. So we are going to see a bunch of graphs. We're going to see that they have some differences and they have some similarities. Now, first of all, this is not going to show up until next week. If you look at the week 11 review session, you'll see this chart. And this chart talks about the fact that degree 1, that means y equals x. Good morning. With an exponent 1. This would be linear. Now, if I have a function such as the parallel goes right there through the middle, even though it looks like it's off a little bit. What if I did y equals negative x? How does a negative in front of that x change what the graph looks like? It doesn't change the y-intercept. What does it change? The other way. Okay, it's going to go the other way. It's going to go down. Yeah, it still has the same y-intercept and they both kind of miss, but it's going to flip it. So a negative in front of the lead term, in this case, there's only one term, flips it upside down. Okay, so we're going to talk about this more. You don't have to write this part down. We're going to talk about this chart next week, but I want you to see that y equals x squared is called degree 2 because it has an exponent of 2. Okay, so it could be plus 7x plus 12, blah, blah, blah. There could be more to it, but any function where the highest exponent is 2, exponent is 2, exponent of 2 is going to make a u. But what if I put a negative in front? What is that going to do? Okay, instead of being a happy face, it's going to be a sad face. Yeah, an exponent in front of the lead term flips it down. So you don't have to write this down. Exponent of 3 looks like this. Okay. What if I put a negative in front of the leading term? It could have other terms, but the exponent will all be smaller than 3. So now if we were in the classroom, we would all be like this. Yeah, everybody. Super embarrassing. So sorry, you guys can't see me. And I don't think even if I turn my camera on, you guys can see me. So picture your arms, okay? Your left arm, your left arm is going down, your right arm is going up. That's what I look like right now. So if I put a negative in front of it, it's going to flip. Okay. So it's going to look like that. I just uncovered the wrong one. It's going to look like that. I thought I was being super high tech with a covering up the answer there. Okay. So degree 4. Now notice, look at degree 2 and degree 4. Degree 2, both arms up. Degree 4, both arms up. These are called even when the highest exponent is an even number. Okay, both arms up. If I put a negative in front of the leading term. Now this could be plus a lot of other terms, right? If I put a negative and when it's positive, I have both arms up. If I put a negative in front, what's going to happen to the graph? Both arms down, right? So it's going to look like that. So notice we are able to predict the end behavior. In this class, we're not going to learn a lot about the middle behavior. You have to take future classes. We know the x-intercept, but we're going to be focusing on the hands, the end behavior. Okay, now let's look at x cubed and x to the fifth. Notice left arm goes down, left arm goes down. Yeah, right arm goes up, right arm goes up. Can you see the similarity between degree 3 and degree 5? Okay, so left arm down, right arm up. If I put a negative in front of it, it's going to flip. Okay, we're going to talk more about that next week. Just a little preview into where we're headed with this. Okay, so the parent graph is exponent of 2 makes a u. So we're going to make a table. -2, -1, 0, 1, and 2. Okay. Oh, do we have calculators? Okay, now super important. When you plug in -2, that means -2 times itself, right? That means -2 times itself when you plug it into the calculator. Now, can you guys see that -2 times itself? -2 times -2 is +4. Yeah, we see that. If you plug, now, first of all, on the calculator, you cannot hit the minus, you have to hit the negative that is down at the bottom below the 0, below the decimal point, the 3, below the 3. You have to hit the negative. Okay, now if you hit -2 and then you hit x squared, you're not going to get the correct answer. Okay, you're going to get -4 because according to the order of operations, you do the exponent before the plus and the minus. So with your calculator, I need you to go parentheses, -2, close the parentheses. Now, how do we square a term on the calculator? You either hit exponent 2, or you can hit the x squared button. So -2 squared is 4, not -4, 4. If you get -4, you didn't hit the parentheses. -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. We're going to choose, that's a very good question. We're going to choose numbers surrounding the 0. No one has ever asked me that question before. I've taught a long time. Right now, we're choosing numbers surrounding the 0. After we shift it, we're going to choose numbers surrounding the vertex, and we'll get to that later. So for right now, numbers surrounding the 0. So that's what you're like, why do negatives? I don't like doing negatives. But because we're surrounding the 0, I want some to the right, I want some to the left, and some to the right. Yes, both sides right now of the 0. It wouldn't give you the shape. Okay, with a line, all you need is 2 points and you connect it. Now that we're getting a more complicated shape, you need a representative to get the full shape. Yeah? That's an excellent question. Okay, so now I'm going to graph 0, 0, negative 1, 1, 1, 1, 2, 4, and negative 2, 4. Okay, this point right here we call the vertex. If the parabola is facing up, it's the minimum value. It is the vertex. It is the minimum value. Now, could I also plug in 0.5 and square 0.5? Yes. Okay, so it's a continuous graph, including decimals and fractions and small parts. Exponent of 2 makes a U. This is a happy U. The parent graph is smiley face, happy U. Okay. Number 2. Now let's make a table. And talk about the parent graph. Okay. We're going to have numbers surrounding 0, 0. Now, according to the chart that we're going to talk more about last week, according to the chart we talked about at the beginning, the parent looks like this. Now, so imagine taking a parabola but now with a cubic, positives go up, negatives go down. So can you see that it's almost like a parabola, except positives go up, negatives go down? That is the parent of the cubic. Okay, and let's see why. So let's take negative 2 with parentheses cubed. That is negative 2 times itself. Can we see why the negatives are going down? These 2 cancel, and I have 1 negative left over. When there's an odd number of negatives, the negative is going to end up still negative. So this is negative 8. Let's try with the calculator. Negative 2 in parentheses, exponent 3. You should get negative 8. Okay, if you include, well, it's going to be negative anyway, but it's good to practice using parentheses, and we're using the exponent button. So negative 2 cubed is negative 8, negative 1 is negative 1, 0 is 0, 1 is 1, 2 is 8. Notice when the exponent is odd, the positives are going up, the negatives are going down. Negatives down, positives up.
Is this the section where we do like the line testing?
That's at the end of this packet. Yeah, because we're talking about functions. Yes, nice. Okay, so 0, 0, 1, 1, 2, 8. Notice it's going up faster because of the exponent of 3. It is a skinnier graph. Okay, but it kind of looks like a parabola where the negatives have been rotated down. Okay, next. What are those little sticks? There's also one called a step function that you see in math analysis, but the straight sticks, in the order of operations, they're in the category of parentheses. But if they're straight sticks, zoomers, anyone? What are those sticks around the X? Absolute value. So the parent graph. Absolute value makes a V. So it's really careful when you do your parabola, your X squared, that has a curved bottom. But when you do the absolute value, it has a point. The vertex comes to a point. So let's make a table. -2, -1, 0, 1, and 2. So absolute value of -2. Absolute value is always positive. So it's going to make it 2. Absolute value of -1 is 1. Absolute value of 0 is 0. Absolute value of 1 is +1. You just make it positive. Okay. So whatever it is, it's just positive. Negatives become positives, positives stay positives. And 2 is 2. So -2, -2, -1, -1, 0, 0, 1, 1. Looks like a V. Notice we're going like at the 45-degree angle, right up the corners. So X squared, exponent of 2 makes a U, curved bottom, absolute value makes a V, pointy. Yes. For today. And then we're going to start to shift them. So, good question. This is the vertex. Bye, have a good day. Notice the vertex went in the middle of my table and I went 2 to the left. I went 2 above and 2 below. So the vertex is the middle of the table. If the vertex moves, those numbers will change. Okay, so I went the vertex and I went 2 to the left and 2 to the right. That's what went into my table, the numbers surrounding the vertex. But for these, we're all going to do -2, -1, 0, 1, and 2. Okay, now the square root of 25 is 5. Everyone agree? 5 squared is 25. Can you see that these are inverse functions? And I hope you didn't write what I'm writing like right here, taking up all that valuable real estate. Like I'm going to erase this because that's valuable real estate right there. Okay, does everyone see that? Square root is an inverse function with squared, right? Square root brings it down, squaring brings it up. They are inverses. So, because they are inverse functions, x squared makes a u, and square root of x makes a sleeping U. Now in geometry last year, if you were in my geometry, you learned something called reflect. Don't write this. Okay. Put your pencils down. Do you remember in geometry, you reflected something across the line y equals x? That's what we're going to do. Okay. So that's why it kind of came up in geometry. You may not remember. Okay. So a parabola looks like this. X squared. Now it would look like this. But if this is the answer, if this is the number 9, what's the square root of 9? Positive 3. Is it negative 3? No. So it looks like half of the U. Okay, it's sleeping, but it's only half because the square root of 9 is 3. The square root of 9 is not negative 3. Okay. Oh, I just lied. I'm going to use different numbers. I'm so sorry. I just told you we'll always use those numbers. Now, I'm going to have negative 2 and I'm going to have negative 1. And we're going to see what happens. But the numbers down below are going to change because I don't want to use decimals. There wasn't, no, that wasn't there. Okay. So with your calculator, square root parentheses negative 2 should give you error. Okay. It is not a real number. It turns out to be imaginary. We'll talk about that in a month. There is no number that you can square and get negative 2. So no real number. Actually is imaginary. Negative 1. Square root of negative 1. Error. No real number. Okay, how about the square root of 0? 0. How about the square root of 1? 1. Now, I'm not going to do 2 because that's a decimal. I'm not going to do 3. I'm going to jump to 4. What's the square root of 4? 2. Okay, so I used nice numbers that I can take the square root of in my head. So 0 is 0, 1 is 1, 4 is 2. And you could see the shape of the sleeping U. It's like the parabola is laying down for a nap and the other part is under the covers. There's no real numbers. It's not there. They are imaginary, so no. So you could see a sleeping U under the covers. Okay, so we recognize the similarity between x squared and square root. They are inverses. Okay, Zoomers, how are we doing? Are you hanging in there? This one's a little awkward to do by Zoom. Okay, good. Now, what you're going to like about this is once you memorize these rules, they're going to apply to all these different graphs. So people tend to like this unit a little bit better than the previous units. Okay, so you're going to learn some rules and then you're going to see that, oh, they all kind of apply similarly. Okay. This is called, some books call it the reciprocal graph. Sometimes it's called the hyperbola. Let's make a table. Now, what I call this is, let's talk about the parent. Now, this looks like an intersection. Looks like cars making right turns. So this car's coming. There it goes. This car's coming. There it goes. Also kind of looks like a butterfly. So that is the parent graph. So let's make a table. -2, -1, leave a space. 0, 1, leave a space, and 2. Because we are going to want to see what happens to the fractions. So 1 divided by -2. Can you see that this is 1 divided by all my values? 1 divided by -2 is -0.5. 1 divided by -1 is -1. 1 divided by 0. Okay, 1 divided by 0 on your calculators. Error. Okay, can you have a 0 under the fraction? No, when the 0 is under the fraction, this is undefined. Can you see that you can almost see the word under in the word undefined? Yeah. Can you have a 0 under the fraction? This would be underfined. Yeah, with a little twang in my voice, it becomes underfined. Okay. 1 divided by 1 is 1. 1 divided by 2 is 1/2, right? 0.5. So let's graph. We have nothing at 0. -2 is 0.5. -1 is 1. 1 is 1 and 2 is 0.5. Okay. We're not getting the whole shape. So let's plug in 1/2. So now we're going 1 divided by 1 ABC 2. So let's practice that. 1 divided by 1 ABC 2. So let's do this by hand. 1 divided by 1/2 is the same as 1 multiplied by the reciprocal, which equals 2. So, sorry, -1/2 gives me -2. +1/2 gives me +2. So this is the reciprocal. Can you see that 3 would give me 1/3? It flips it. Whatever it was, it flipped it. So everybody, Zoomers, if I plugged in, this is the reciprocal function, and it takes whatever it was and flips it, 1/3 will give me, ding, ding, ding. Yeah, Zoomers, can we see that 1/3 gives me 3? So -3 gives me 1/3. -1/3 gives me 3. Can we see the shape? No. Same thing here. This is wrong. Okay, you will never touch the x-axis. That is not touching. It looks like it's touching. That is not touching. I made this point too low. You will never touch the x-axis. And we can talk about why that's true more. So here's the parent graph. Okay. Near. So memorize the shape. Okay. This will show up on your test. You're going to graph 1, 1 and negative 1, 1, and you're going to go, that's it for now. And then we're going to come back to it later. I just want you to memorize the shape, and we're not going to move it or scoot it or anything. Okay. Now, what if I put a negative in front? Okay, it's going to flip it. So we are just going to sketch the parent. We're not going to make a table. Okay, so negative x squared is a sad u. We're sketching the parent graph. What if I have a fraction less than 1 in front of the leading term? Okay, so in gray, I know you guys don't have gray. In gray, here was the original parent graph, somewhere around there. Okay, if I put a fraction less than 1, in between 0 and 1, in front of it, is it going to climb more slowly or more quickly? Everyone make a guess. Zoomers, make a guess. If I put a fraction in front of the x squared, is it going to climb quickly or slowly? No, it's going to climb slowly. And we can see why by making a table. In fact, if you want to look at last year's video actually made a table. Yeah, does that make sense? A fraction less than 1, absolute value less than 1, climbs more slowly compared to the original. What if I have a number greater than 1? So I'm going to sketch the regular parabola. Okay, so we're just sketching the parent graphs. So now, if I'm going to take all my y values after I square them, I'm going to multiply by 2. That is going to climb more quickly. Okay, so if there's a number greater than 1, it becomes a skinny graph. It climbs more quickly. Okay. Now, notice we are going to move the vertex. Okay. So does everyone see that this is x minus 1 plus a 0 on the outside? Okay, so far? So first, let's talk about the parent. What does absolute value look like? What is the graph? It's the 2 sticks. Absolute value, peeking at the first page, looks like a V. Okay, there's no negative in front. That too. That too. Okay. Absolute value makes a V. So next I want the vertex. So it's not going to be 0, 0 anymore. Now, this right here, if it's inside the parentheses, inside the absolute value, either parentheses or absolute value, I need the opposite sign. So the vertex, the x coordinate of the vertex is the opposite of what you see inside those absolute value sticks. So it's going to be +1. Yeah, everyone was paying attention to that, right? Inside the absolute value, inside the parentheses, it's the opposite of that number. Now, the one that's out here is the same. So it's 0, 1, 0. Now, I'm going to make a table of only 3 values. I'm going to take my vertex and I'm going to put that in the middle of my table. Okay, so let's check it. Let's check 1. If I plug, excuse me, if I plug 1 in for x, I get absolute value of 1 minus 1. Can we see that that's equal to 0? So it worked. Okay, now we're not putting the same numbers. This point needs to be to the left of 1, and this point needs to be to the right of 1. So fill in those 2 x values. I'll be right back. Okay, what's going to go right here? 0. Yeah, to the left of 1. And what's going to go right here? 2. 1 to the left, 1 to the right. Okay, it's making it cluttered. Okay, let's plug it in. Absolute value of 0 minus 1 is the absolute value of -1. But absolute value makes that number positive, equals 1. Now, if this is really a V and I've really found the vertex, the left point and the right point should give me the same values, right? We have the middle and then we have 1, 1, 2, 2. They're all going to have little buddies and be the same. So absolute value of 2 minus 1 is the absolute value of 1, which equals 1. Yeah. Okay, if this is a V, these values should be the same. So is absolute value a U or a V? A V. So I'm going to graph 0, 1 and 2, 1, and absolute value is a V. Okay, so we found the parent, the vertex, and we made a table. Number 10. Okay, parent. Absolute value makes a V. Vertex. Can we see that this is really absolute value of X plus 0? Okay, time to tell me or type in if you're a Zoomer. Take a guess of what the X coordinate of the vertex is going to be. And I'll play thinking music for you. Do, 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 do. Yeah, Zoomers, what is the X coordinate of the vertex going to be? Yes. The X coordinate is going to be 0. Yeah. Okay. The Y coordinate. So this is opposite sign. And this is same sign. What is the Y coordinate of the vertex going to be? Positive 4. Let's make a table. 3 values. And what goes in the middle of my table? 0. And if I plugged that in, I would see that indeed I get 4. Okay, so X is 0. I want 1 to the left and 1 to the right. So to the left is going to be what, Zoomer? Oh, very good. Thank you. To the left is going to be what, Zoomers? What's going to be to the left of 0? All right. -1. And to the right is going to be 1. Yeah. So we have 0, 1 to the left, 1 to the right. Okay. Now we need to plug in absolute value of -1 plus 4. Absolute value is always positive. Plus 4 is 5. Y equals absolute value of 1 plus 4. Absolute value is 1 plus 4 is 5. If this is absolute value, 1 to the left and 1 to the right, those should match. And they do. So 0, 4, -1, 5, and 1, 5. There is my V. So parent graph, vertex, table of 3 values.
Oh, so what is the 109, the one was inside of it?
Yes.
So what is outside of the?
Yes. Okay, good point. Notice this was the vertex here was +1, 0, because that 1 is inside. Okay. The vertex here is 0, 4, because the 4 is outside. Super important. Number 11. Parent. Okay, see this negative right here? The parent graph is an upside down V. Vertex. So to find the vertex, we look and see what is inside. That's going to give me the X coordinate. And we look and see what is outside. That is going to give me the Y coordinate. For the X coordinate, we need the opposite sign. For the Y coordinate, we need the same sign. Okay, let's take a guess. What do you guess the vertex is going to be? Okay, Zoomers, take a guess. What do you guess the vertex is going to be? There you go. The X coordinate is going to be 0. The Y coordinate is going to be -1. Opposite of 0 is 0. The outside number is the Y and the sign does not change. Okay, table of 3 values. 0, -1 becomes the middle of my graph. 1 to the left is -1. 1 to the right is +1. So you have to be really careful here. Y equals negative, plug in -1 minus 1. Really careful. Okay, remember, order of operations, parentheses, exponents, multiply, divide, add, subtract. Absolute value is up here. It's not just parentheses, it's any grouping symbol. Okay, so absolute value is here. You do the absolute value. Absolute value of -1 is 1. These do not cancel each other. Do not cancel. Now with this one, it is actually easier to do parent graph, vertex, and sketch the graph than it is to make the table because people make arithmetic errors. So this is -1 minus 1 is -2. So let's plug this. -1, -2. 0, -1. Are we starting to see an upside down V? Does anyone want to predict what this one's going to be? I hope it's -2. Yeah. So let's do it. Y equals negative of 1 minus 1. -1 minus 1 is -2. So you can see that predicting using the parent graph is easier than the arithmetic of calculating the table. Okay. Number 12. Parent graph. Okay. So square root is a sleeping parabola. Notice only one arrow. Square root is a sleeping parabola. vertex. So use the rules similar to the previous ones, even though it's a different function. Now, notice the -2 is inside. I'm going to write a +0 outside. So the vertex is, yeah, take a guess, type in the vertex. And you're going to have to think which one's X, which one's Y, same sign, opposite sign. So do we have a guess? Careful, not quite, but that's a good guess. The X coordinate is +2. Yeah? Yeah, does that make sense? The X coordinate is +2. The Y coordinate is 0. +2, 0. And you're going to start to notice a pattern. Opposite sign for the X, same sign for the Y. Okay. For this one, we're going to do a sketch, no table. Because the table is just going to give us negatives anyway, or decimals. So I'm going to graph the vertex is 2, 0. Sometimes we'll do a table. But right now, we're just going to do a sketch. We're just focusing on the vertex. Make sense? Okay, let's try another one. The parent is a sleeping parabola. The vertex. So the question is that 4 inside or outside? It's outside. If the 4 is outside, is that the X or the Y?
X is inside.
X is inside, Y is outside. So this is Y, same sign. And inside is X, opposite signs. Okay, Zoomers, you with me? All right. So Zoomers, please guess the vertex. Yeah, Zoomers, give it a try. You could do direct message if you don't want anyone to see your guess. Okay. The X coordinate is, drum roll please, 0. The Y coordinate is 4. Okay. So for this one, for today, we're just going to graph 0, 4. And we're going to do a sketch. For one thing, we're running out of time. Sleeping U. 0, 4 is the vertex, and it's a sleeping U. Number 14. What is the parent? What is the vertex? If anyone's a Monty Python fan, I sound like that guy. What is your favorite color? What is the airspeed of an African swallow? Okay. Parent graph, vertex, and sketch. Okay. By the time we get to the end, it'll be parent, vertex, and a short little table, but we're not doing that right now because we're out of time. Okay, parent graph, sleeping U. Yeah, it's asleep and the bottom half of the U is under the covers. Okay, Zoomers. Type in the vertex, please. Careful. Oh, good guess. Okay, what is the x coordinate of the vertex? Oh, wait, did you switch or did you not switch? Oh, yeah, switch. Yeah. Okay, the x coordinate of the vertex is -1. Yeah, does everyone see that for the x coordinate, you grab the inside number and opposite sign? Okay, Zoomers, you ready to try again? What is the y coordinate of the vertex? Ding, ding, ding. -5. You grab the outside number, same sign. Okay, so -1, -5 is the vertex. Sleeping parabola, we're just drawing a sketch. Okay, number 15, do not do. I'm kind of worried that not everyone knows how to do these, but we don't have time today. And I don't think we did them. Sketch 12, 13, and 14. We're just doing parent graph, vertex, sketch. Yeah, we did those. Okay, we're not doing these. -19. So find P of -3. That's what that says. Now, there is only one variable here. There is a variable and there is a function name. What is the variable? The variable is x. What is the function name? P. So instead of y equals, okay, so in the past, you just saw this, y equals, right? So it's the same math, it's different notation. Now we're going to say P of x equals. So P is not a variable. X is the only variable. Okay, so what that means is P of -3. So what are we going to do with that -3? We are going to plug it in everywhere we see an X. So P of -3 is parentheses -3 cubed plus -3. Notice when you plug a negative number in, plug it in with parentheses. Calculator, parentheses, -3 to the third power. Practicing with your calculator, you get -27 plus -3. In your head, -27 plus -3, same sign sum, will give you -30. That's fine. On a test, use a calculator. Don't lose points because you were being admirable and doing it in your head. Okay, so I want P of -1. What is the variable? T. And what is the function name? P. Again, it's not always P. So instead of y equals, we say P of t equals P of t. Okay, so P of -1, we're gonna plug it in with parentheses, the only place where you see the T. So -1 squared is 1 minus 1 equals 0. Oh, wrong. Oh, typo. Thank you. I'm sorry. -5. So 1 minus 5, P of -1. Sorry about that. What's 1 take away 5? -4. Sorry. Thank you for good catch. Started looking ahead. How much more do we have to do? Okay. Now, look at this. If I plug in 1, I get whatever I get, 1. But look at this one. If I plug in 1, could I get a +1 and a -1? No. Okay. Can we see that this is a function and this is not a function? So we're going to use what is called the vertical line test. Now, is there any point on the graph where I can draw a vertical line and hit it 2 places? Yes. So this fails the vertical line test and it's not a function. Here, there is nowhere on the graph where I can draw a vertical line that will hit the graph more than once. Function, not a function. Sorry. Whoa, I'm losing it. Not a function. Woo! I am decaying as you see me. Okay. So I want G of 1, right? That's how you say that. G of 1. That means if 1 is the X, what is the Y value? So let's find X equals 1. That is the point. That is the line X equals 1. Everyone see that? What is the Y value when X equals 1? Right there? What is the Y value when X equals 1? -3, right? Okay, now I want G of -4. So the X value is -4. Here is X equals -4. There you go. Yeah. When X is -4, what is the Y value? -1. Just find the Y. Find it the where the blue point is, if it's blue. Okay, so now let's look at this right here. G of 1 is -3 plus G of -4 is -1. Same sign sum. -1 plus -3. -3 plus -1 is -4. Okay, what's G of -1? Here's -1. Here it is. So G of -1 is -5. Okay. What about G of 0? -4? G of 0? Okay. G of -1 is -5. G of 0 is -4. It says right here to add them, which is -9. Okay, I'm going to cross this one off. I'm going to say do not do. If this doesn't make sense and you want to see me do it, we could do it at the end. So the notation is difficult. The math is not that bad. So this line, what do you think it's saying to do with my answers once I get answers? Divide, right? So this is saying plug 9 into G and plug 9 into F and then divide them. My G's and my 9s. G of 9 and F of 9. Okay, I'm going to plug 9 into G. That's 81 minus 5 is 76. I'll write that out. 81 minus 5 is 76. Okay, F of 9 is 36 plus 5 equals 41. Can I reduce? No, that's done. So this is saying take F of -2, multiply it by G of -2. So F of -2 is 2 times -2 minus 5, which is -4 minus 5, which is -9. G of -2 is 3 times -2 plus 2, which is -6 plus 2, which is -4. -9 times -4 is positive 36. Notice 25. There's no letter there. I mean, there's no number there. There's no number there. I need to take a break. Okay, anyway, we're going to finish this up. So we have H of N plus G of N. Okay, h of n, replace it with n minus 5. G of n, put a plus sign in the middle, right? G of n, replace it with negative 2n plus 3. So combine like terms. N plus negative 2n is negative n. Negative 5 plus 3 is negative 2. Now notice, last week, we did not learn any new material. Okay, we just focused on taking last week's test. This week, it's kind of a lot. And this is a whole week's worth of material. And we have one more. Yay, but it's the hardest one. Oh. Okay, so this is g of x multiplied by f of x. Everyone agree so far? So this is 3x plus 2 multiply, don't put an x. I know photomath will put an x, don't put an x. Multiply by x squared minus 5x. Now, before we do anything, is anyone wondering if I missed something? Should I put something? Oh, okay, that's not what I meant, but x cubed minus 5x. Okay, now you are absolutely correct. Does anyone feel like I should put something? Yes, ding, ding, ding. Okay, I'm not going to put a time sign. I'm going to put parentheses. Yeah, because it's all of this times all of this. Now, notice I have 2 terms by 2 terms. If I have 2 terms by 2 terms, the next step is to make a two terms by 2 terms, make a sandwich. No. Make my bed. No, although I need a nap. Make a box. 2 terms by 2 terms. So we have 3x plus 2, and we have x cubed minus 5x. The box is not gone. No, it's coming back. No. Yeah. Okay. 3x times x cubed is 3x to the 4th. Three x times negative 5x, negative 15x squared. 2x times 2 times 3x is 2x cubed. And 2 times negative 5x is negative 10x. Do I have any like terms? No. 3x to the 4th. I'm going to put them in order. Plus 2x cubed minus 15x squared minus 10x. We are done. That was exhausting. Are you exhausted? I'm exhausted. Oh, chemistry and then this. Okay, now don't forget, if you get home and you're looking over this and you realize, whoa, I totally zoned over number 7 or whatever it was, go back and watch the video, because I will have the video. To find the video, you